Good evening, friends. I am recording this lecture. Sorry about I could not attend face-to-face lecture because I was sick and I thought that I couldn't do it. That's why I stayed at home. Actually, I was planning to do it face-to-face another day, but Sedef Hoca told me to make it online. I'm going to do this lecture online, so it will be recorded and it will be on Moodle. By the way, if any of you wants to attend to the lectures on Friday, I mean tomorrow, you are welcome. So you can attend face to face. So maybe by this way it will be better because we will have a recorded lecture, and also you may see the same lecture face to face if you want. Okay, I hope more people will come. If you have any question, you can just, it is better to text to me because otherwise normally sometimes I can hardly understand some talking, so it will be harder for I mean online lectures. So it will be better to ask from messenger. I mean the messenger of the Zoom. Okay. Let's start. First of all, let me to share my screen. These slides are from last semester. I will take some of them and send to you. What did we do last? Okay. So previous lecture, we just watch some videos related to some terms that we've seen before. So my aim was to make you better understanding, and also you can, they are on Moodle, you can also just check it later. So we saw first come first serve algorithm. Let me to just, by the way, let me to say first, normally we have 6 types of process scheduling algorithms. One second, please. Okay, let me to continue. Oops. We have 6 types of process scheduling algorithms that operating system is using. Some of them are non-preemptive, some of them are preemptive. What did we say? The non-preemptive kind of algorithms is not checking the situation, some situation. I mean, when a process is in execution, if any higher priority process comes into the memory, it will not consider it. It will, the system designed to finish the current process execution. But in preemptive one, in this case, in same situation, the execution, the process that is in execution, it will be interrupted, and the higher priority process will take place. So here, some of the algorithms are preemptive, some of the algorithms are non-preemptive. And some of them are just the preemptive version of non-preemptive algorithms. For example, the first come first serve algorithm is non-preemptive. Round robin scheduling algorithm is a kind of preemptive version of that. Or shortest job first scheduling is non-preemptive, okay? But some other algorithms are non-preemptive. So we will see also these things. So while we check the algorithms, we will check their also preemptive or non-preemptive nature. So the first come first served, as I told you, it is a kind of non-preemptive algorithm. We saw this before, so I will not continue to explain it. I will give a homework. Actually, I'm planning to do the shortest job first algorithm, and if I have time, a round robin algorithm, and I will give a homework related to all of them. Okay, the shortest job first algorithm is the other kind of non-preemptive algorithm. So here it is checking the shortest job time. What does it mean? If you remember, in first come first served, the convoy effect, what does it mean? Because of its nature is first come first served, the first algorithm, if the first coming algorithm into memory, if its execution time is so long, I mean, for example, the others are 3-5 nanoseconds or something, but the first job is 40 nanoseconds. So in this case, it will be a convoy effect. And because of this convoy effect, it will be a starvation. So in this kind of situation, maybe it will be better to check shortest job first. So instead of applying first come first served algorithm, it would be better to apply shortest job first algorithm, which it will check the shortest job and it will execute the shortest job first. So okay. So we will continue from shortest job first scheduling. As I told you, in first come first served, we will just order the processes according to their arrival time. When they come first, they will serve first by the CPU. In shortest job first, it is scheduling the processes according to their burst time. So just 1 second. Sorry again. Huh, okay. I'm trying to do put something that can't I? Huh, okay. Okay. In shortest job first scheduling algorithms, it is scheduling the processes according to their burst time. Okay, so we are checking the lowest burst time. What was burst time? The execution time. How much time a process needs to be executed by the CPU. Okay, so let me to okay. The advantages are, I don't know why I am trying to put this, and it will not let me to. Okay. The advantages of shortest job first is maximum throughput. What is maximum throughput? It means you can put execute more processes. Think about that. In a situation, think about that in a situation like this. Check the burst times, 43 and 1. In first come first served algorithm, we can we can execute, how can I say, 43 processes in 44 nanoseconds, or 2 processes in 43 nanoseconds. But in shortest job first, think about that. Also, I will say you the arrival. Do not consider the arrival time. But if we check the burst times, we can execute 2 processes in 4 nanoseconds. So the throughput will be increased. And also, it is going to make minimum average waiting and turnaround time. So don't say me that the average waiting time will be same, because these 2 processes can wait this process only a few nanoseconds, but this process can make to wait about 40 nanoseconds, the others. So average waiting time will be less, and also the turnaround time as well. Okay, so one of the disadvantage is may suffer with the problem of starvation. We will check that later. And also it is not implementable, but we don't care about it. Actually, in real time, in real systems, we can't know all the processes execution time. It is something like that. If it is a process is, how can I say, it needs to be started and calculate something. You can estimate it, but if it is a kind of process that if it is a kind of process that if it is a kind of process that a person, the user, should stop it, in this case, we can't know when the user stopped the process. So it is talking about this thing. Okay. Yes, I am. That's so. In shortest job first example. Also, I think you remember that we will have only the process ID, arrival time, and burst time will be given. So this part will not be given to you. Okay. So this part are the, I mean, this part is the part that you have to calculate or find it. Okay. How I can. Just 1 second. Okay, to solve it, how can I do it? Just 1 second. To um, 1 second, please. Okay, I'm back. Okay, I thought it would be better to, this is, by the way, shortest job first. In classroom, it will be more comfortable for me to just solve this example, but here I will try my best to do it in online lecture. Let's make it bold. Okay. So in shortest job first, what is our main aim? We are checking the shortest burst time. But let me to just make a Gantt chart. It will start from 0. Okay. But when the time is 0, you have to think like that. You have to think two things. The first thing is the burst time, but the second thing is the arrival time, because it is something like that. Till, I mean, the beginning, the middle of, till, how can I say, 2010 or till 2006, let's say. If someone asks the people who is the best player ever, people should say Pele or Ronaldo, Pele or Maradona. But after, for example, Messi and Cristiano Ronaldo, I mean, after 2006 or 2008, I don't know the dates exactly. If someone asks who is the greatest player ever, now we have 4 candidates. Someone will say Ronaldo, someone will say Messi, someone will say Pele or Maradona. So, so the things may change according to the time. Okay, I have a message, not a question. Okay. So the thing is, I am trying to say, any process may have the shortest burst time, but I can't execute it first if it is not arrived first. I mean, if it is not arrived in time 0, I can't execute it first. Yes, you have a question or just if you have a question, it is better to text to me. It is better for the lecture as well. So while I'm doing the Gantt chart, which one I should maybe I have to take the Gantt chart and show you from there. It is easier for me to see instead of drawing it. Because From the table, it is not easy to understand, but from Gantt chart, I think you can understand. So I am trying to say that you can't just start to execute a process if it is not arrived yet. It doesn't matter its burst time is very small. So first of all, we will check the arrival times. So which one is arrived first in the ready queue is this one, process 1. So it will execute 7 nanoseconds. From 0 to 1, it is CPU is idle. It is not doing anything because no process is arrived at time 0. It is like the students that they are arriving late. Think about that. Teacher is waiting for the students. Teacher came on time, for example, at 3 o'clock, and students start to come after 5 minutes. So it is something like that. Teacher is idle in 5 minutes. So also here, the CPU is idle 1 nanosecond. And when it is executed, because of its nature is non-preemptive, once a process is started to execute by this CPU, it will not interrupt it. So when P1 is arrived, it doesn't matter how much time it will be executed. CPU should execute it, but it was a preemptive one. It can be interrupted by a higher priority process or something like that. Anyway, so when time is, it is executing till time is 8. So when time is 8, sorry about that. When time is 8, which processes is in ready queue? Okay, I am assuming that about 20 people are 17 people with me, 16 people without me are listening. So I am asking this question to you, if anyone can answer.
Yes, sir.
When the time is 8,
Yes, sir.
which processes is in ready queue?
The P3 is there.
Yes. What else?
We also have P2, but the boy.
Okay. Now look. We first check which processes are in ready queue. Process 1 is executed, so it is not in ready queue anymore. But
Process 2 and 3.
Sorry, process 1 is not in ready queue anymore because in time 8, it is finished execution. But
I said 2 and 3.
Okay. No, I am I am saying same thing, but I am just adding extra things. What about process 4? Do not consider the burst time first.
Is also available.
Process 4 is also in ready queue. I'm not talking about which one is the shortest burst time. I am saying when time is 8, which processes are, it should be R, also it is fixing me, in the ready queue, okay. So the second question, sorry about that, can I make it smaller? 1 second, please. Okay. The second question is second question. 1 second. Control X. Okay, I saw you, Isaac. You can text me or you can write. You can talk. Which process has less burst time? P2.
Hello.
Hello, Isaac.
Yeah, let me answer this question. P1 has less burst time.
P1?
Yes.
No, P1 is already executed. When time is, I'm talking about the time starting from 8 nanoseconds. So P1 is executed, already executed. It is a write first. Because of that, CPU didn't consider the burst time, so it is executed. What about the other processes? When time is 8, we have 3 processes inside.
P3.
P3 execution time is 2. So P3. I say nanoseconds, we can say units, I will tell you in the question, so don't worry about that, where I found that nanosecond. It is just, you can say 2 units if it is not mentioning, or 2 nanoseconds. Okay, so what will happen? The next one is P3, so P3 will be executed. So from 8 to 10, P3 will be executed. And the other question is, other question is, by the way, I am trying to find how can I fix anyway. So let me to ask another question. We are recording it, so it is not we lost. The next thing is, when time is 8, which processes are in the ready queue? So let me to think about that. Which processes are executed? Process 1 and process 3 are executed. So in ready queue, we have, when time is 10, I can say all the processes are in ready queue. I mean, except the executed ones. So process 1 is not there. Process 2, process 3 is executed, so I will not count it. Process 4 is there.